Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Hamizan Berasli. My metric number is B0920100341. Today we will present our solid mechanic BMMM2303 assignment, which is force and factor of safety analysis from actual structure. Our group consists of 5 group members, which is me, myself, Afi Aizat, Ahmad Abdurrahman, Zafran bin Zaroi, and Said. Introduction for our project is the factor of safety or safety factor is very important in engineering design. While designing any engineering product or component, safety is utmost importance. To ensure the safety of those items, each component is designed to bear more loads than its actual operating loads. What is safety factor? The load carrying capability of a system beyond what the system actually supports is a safety factor. Bridges, building, safety equipment and fall protection are all built with a safety component in mind. Simply expressed, the safety factor refers to how strong a system is then it is necessary. Engineers treat the safety factor, which is the foundation of all construction and safety devices. How do we analyze actual structure for actual structures force and safety factor? First, we create an idealized model of the structure. Second, we state structure assumption. Next, we create an FBD. Number 4, we create equation of equilibrium. And then we analyze the force operating on the structure, and last but not least, we determine the system maximum permitted forces and safety factor employed from the actual diagram.
Assalamualaikum warahmatullahi ta'ala wabarakatuh. My name is Muhammad Zafran bin Zairoi. My metric number is B0920100260. So in our presentation, we choose a bridge for our actual structure. The purpose we choose this bridge because it had two poles that can withstand the force that will apply on it. So next is for the free body diagram. So this is the free body diagram that we make for the bridge for our actual structure that we choose is bridge. So the type of material of the bridge is concrete. It have the ultimate tensile strength, which is for 300 megapascal. So the force that will apply on the bridge, we assume as 40 kilonewton per meter. So for the two poles, we assume that each of the poles is 0.5 kilonewton per meter. I'm sorry for this error. So from one pole to another pole, we have 2 meter distance, and then at point A we make our moment here, so it will be moment A. So at the moment A, it only have Fy only. So for another point is we assume this as the point B. So the point B is a roller support that has Fx and Fy. That's all from me. Thank you.
Assalamualaikum. My name is Muhammad Afiq Aizat bin Cik Azman. Metric number B0920100442. For the concentrated load, we have changed the distributed load to the concentrated load by divide the distributed load with the length of the beam. We can assume that the load given is distributed in uniformly. The A is the fixed support, and that only have the force at the y-axis, while the B is the roller support that have the force in the both direction, y and x-axis. For the equation of equilibrium, we must find the reaction force of the beam first. To find the reaction force, first we have to find motion at the joint A. To get the force Y at the joint B. After get the force Y at joint B, we can find the force Y at the point A using summation Y equal to 0.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Ammar bin Abdul Rahman. Metric number B0920100311. Today I'm gonna present about factor of safety. As we know, the equation of stress equal to F over A. Firstly, we need to find the allowable stress, which is we got 600, 1252 Pascal, and then we need to find the ultimate stress, which is 300 megapascal. So in case we need to find the factor of safety, we just divide 300 megapascal to the allowable stress, and then we get the factor of safety. The factor of safety is the ratio of the allowable stress to the actual stress. Factor of safety of 1 represent that the stress is at the allowable limit. A factor of safety of less than 1 represent likely failure. A factor of safety is greater than 1 represent how much the stress is within the allowable limit. That's all. Thank you.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Thank you for the previous speaker. So we continue for the next slide, which is about discussion. So for discussion, based on our calculation, we obtain the value of safety factor, which is 498.96, which is greater than 1. So in general, a high factor of safety means a heavier component, more upscale material, and improved design. A factor of 1 means that the stress is at the allowable limit, which while less than 1 means likely a failure. So for the conclusion for our project, at the end of the project, we have successfully analyzing the forces and factor of safety from the actual diagram. The mechanical properties such as bending moment and shear force has been calculated based on the free body diagram, and the assumption force applied on the bridge. Therefore, we know that the equilibrium of bridge have their own bending moment, shear force value. Last but not least, we can analyze the maximum allowable force for the system and the factor of safety on this actual diagram. So I think that's all from me. Thank you.